Who said the atom was elementary? The beginning of our journey in search of the fundamental constituents starts from the moment when we discovered that our elementary atom was not really elementary. There was a structure in that atom, and so it lost its status as fundamental. Who made it non-fundamental was Thomson. Thomson was exploring the properties of cathode rays, and in 1897 found that those rays were made of corpuscles with negative electrical charge. Therefore, there should be a region where there was a positive charge. There, the atom has structure now, and to compile these findings, Thomson proposed his model, the Raising pudding. In 1895, at the University of Cambridge, Rutherford begins to conduct some studies in Professor Thomson's laboratory. Rutherford was not interested in the atomic structure, but in a new phenomenon, radioactivity. He observed that not all the particles emitted in the disintegration, when trying to cross a thick wall, reached the other side, and some of those who could were diverted from their initial trajectory. Rutherford used the atomic model of Thomson to describe this trajectory deviation. He used a thin gold leaf so that only one atom was responsible for the spreading. Rutherford did the calculations with Thomson's model, and what we hoped was that the particles should be scattered at very low angles and hardly find particles coming back from the clash with the leaf. But that was not what the experiment has shown. The particles were much more deviated than expected. Rutherford burned the Raising pudding, and he saw the need to change the recipe of the atomic model. Moreover, his calculations showed that there was a region with practically all the mass of the atom positively charged. The solution he found was to move the electron away from the positive region, and in order to keep it that way, the electron should be in orbit. The positive region is now called the atomic nucleus, and the model planetary. Rutherford was then able to explain the phenomenon he observed in the gold leaf. The scattering observed now made sense. 2 years later, his student Bohr realizes that his model should not be stable because electrically charged particles, when crossing circular paths, emit electromagnetic radiation, losing energy. This would result in a return to Thomson's model. But Bohr considered the planetary idea too beautiful to be wrong. Thus, he proposed that the electrons would be in orbits of energy levels with fixed quantities, which we can call quantized levels. The model was then corrected. Rutherford knew that the repulsion among the protons would not allow a stable nucleus. But what if there were particles without an electric charge? They could reduce repulsion and allow stability. Thus, in 1932, Chadwick observes a neutron, completing the atomic model of the first half of the 20th century. How did he do it? Well, one way to observe the neutron is this. Hydrogen has only one proton, helium has 2, lithium 3, and so on. By measuring the mass of these elements, they are expected to have masses corresponding to their protons. However, sometimes this does not happen, and the mass observed is greater. This excess of mass stands for the existence of an uncharged particle, the neutron. As you might imagine, this atom will appear years later as made of other particles, being even less fundamental and elementary.